Hi students, welcome to another video of Smartly Learn. In the previous few videos, we have been trying to calculate the value of k in an input function. In this particular video, we are going to calculate expected values given alpha and betas are the zeros of a particular polynomial. Depending upon how many subdivisions are there, usually this type of numerical comes in a detailed answer. So let us take the input for now. If alpha and beta are the zeros of the quadratic polynomial, p of x is equal to x squared minus 5x plus 6, find the value of alpha square plus beta square, alpha cube beta square plus alpha square beta cube. Then the third subdivision is alpha minus beta, and the fourth subdivision is alpha cube plus beta cube. So let's calculate one by one first. So let's note the input polynomial. It is x squared minus 5x plus 6. I'm going to list all the conditions here so that we are going to use them for calculation. Alpha squared plus beta squared. The second condition is alpha cube beta squared plus alpha squared beta cube. The third condition that we are going to calculate is alpha minus beta, and the fourth one is alpha cube plus beta cube. So let's first calculate what is alpha plus beta for this input and alpha beta. So alpha plus beta in this case is minus b by a. So minus of minus 5. So it is 5 by 1. So just 5. Alpha beta is c by a. Here c is 6, a is 1. So it is just 6. Now let's start to calculate what is alpha square plus beta square. So for alpha square plus beta square, we'll go back to the class 9 polynomial lesson. So we know that alpha plus beta the whole square is equal to alpha square plus beta square plus 2 alpha beta. I'm using the formula a plus b the whole square is equal to a square plus b square plus 2ab. I'm going to substitute all the values that I know of. So in this case, I know the value of alpha plus beta is 5. So 5 square is equal to alpha square plus beta square plus 2 into, we calculated the alpha beta to be 6. Okay, so 25 is equal to alpha square plus beta square plus 12. So I'm going to take the 12 the other side, which means alpha square plus beta square is going to be equal to 13. Okay, now this is about the first subdivision. Let's move on to the second one. In the second one, the input is alpha cube beta square plus alpha square beta cube. I'm going to take the common terms outside here. So in this case, alpha square beta square is something I have to take as common terms. So what is left in the first one is just an alpha. In the second term, it is beta. So I have reduced the input as alpha square beta square into alpha plus beta, which is nothing but alpha beta the whole square into alpha plus beta. So I'm blindly substituting the value. Alpha beta is 6. So 6 the whole square into alpha plus beta is 5. So this is equal to 36 into 5. So 36 5s are 180. So the answer for alpha cube beta square plus alpha square beta cube is equal to 180. Now let's try for the third one. The third thing that we're expected to calculate is alpha minus beta. Now, in order to understand alpha minus beta, let's go back to a revision of polynomials. We know that alpha minus beta, the whole square is equal to alpha square plus beta square minus 2 alpha beta. This is a minus b the whole square is equal to a square plus b square minus 2ab. Now I need to find the value of alpha minus beta. I have already calculated as part of the first expression what was the value of alpha squared plus beta squared. So I'm going to use that for continued substitution. In the first term, the first subdivision, we calculated this value as 13, alpha square plus beta square. So I'm substituting that 13 minus 2 into alpha plus beta is actually 6. So this is 13 minus 12, which is 1. And we know alpha minus beta is equal to square root of 1, because alpha minus beta, the whole square, is what we calculated as 1. So I need to find the value of alpha minus beta, which is square root of 1. So alpha minus beta is equal to 1. So that is the value for the third expression. Let us calculate the value for the last one, which is alpha cube plus beta cube. This is of the format a cube plus b cube. So let's go back to the formula of a plus b the whole cube. That is a plus b the whole cube is equal to a cube plus b cube plus 3ab into a plus b. So I have written this in this style. What is required for us to calculate is this value alpha cube plus beta cube. So I'm going to take this entire expression to the left hand side to simplify. So alpha cube plus beta cube is equal to alpha plus beta the whole cube minus 3 alpha beta into alpha plus beta. Now we know the values of all these terms in the RHS, so I'm simply substituting. Alpha plus beta is 5, so this is 5 cube minus 3 into value of alpha beta is 6, so that is 6 plus alpha plus beta again, which is 5. So this is 5 cube is 125 minus 6 3s are 18. 18 into 5 is 90. So when I subtract 90 from 125, I get 35. Value of alpha cube plus beta cube is equal to 35. We'll try to take up a similar problem like this in the next video as well and solve them. Please extend your support to me by subscribing to my channel Smartly Learn. You can also reach out to me through my website www.smartlylearn.in for more practice worksheets. Thank you. See you in the next video. Bye.